Hello, I'm Eric Horvitz, Chief Scientific Officer at Microsoft. It's my privilege to moderate a discussion on large-scale neural platform models, opportunities, concerns, and directions. I'm joined by three fabulous colleagues, Percy Liang, Yejin Choi, and Miles Brundage. Percy is an associate professor of computer science at Stanford University. His research spans numerous topics in machine learning with a focus on natural language, including robustness, interpretability, semantics, and reasoning. Yejin is a professor at the Paul Allen School of Computer Science and Engineering at the University of Washington. Her interests are rooted in natural language and machine learning, including grounding of meaning and common sense reasoning, spanning common sense about the physical and social worlds. Miles is a research scientist at OpenAI, where he heads up policy research. He focuses on the responsible governance of AI, and he's been a voice for quite a while around AI safety and longer-term futures. Percy, Yejin, and Miles, thank you so much for joining me today to discuss an important and interesting constellation of topics, all coming to the fore quite rapidly over the last 5 years or so, with the rise of an interesting paradigm of AI research I viewed as a tidal shift in an approach based on leveraging large-scale neural language models, massive models built via self-supervised machine learning. Now, a relatively small number of large-scale neural models have evolved into veritable computing platforms for AI R&D, where fixed large-scale platform models are adapted via a fine-tuning methodology to develop capabilities on specific tasks. While there's great excitement about demonstrated capabilities, the models as platforms paradigm is at the same time raising questions and concerns, including on the nature and understandability of emergent behaviors, on the safety and robustness of the models, and concerns about costly failures, such as the potential for these systems to generate offensive or misleading output, worries about misuses for new powers these models can give to malevolent actors. These questions are made even more salient with recent work that aims the methods at new tasks like code generation and recommendation. These kinds of applications have even more direct connection to actions being taken in the open world. And an overriding challenge that we're seeing coming into the community is the cost of building these core platform models, leading to haves and have-nots, where only a few industry organizations can construct the platform models. So I'd like to spend our time today discussing these issues, all coming in the context of the buzz of interest around the rising centrality of large-scale neural platform models. Let's jump in now with some questions. So Percy, any kind of surprising emergent behavior draws great attention in AI research per the implications that something bigger than expected is coming out of the methods, and that we might leverage these new capabilities for leaps forward. How would you characterize the nature of the emerging capabilities of these large-scale neural platform models?
Yeah, thanks, Eric, and thanks for having me on the panel today. This is a topic that's really near and dear to my heart these days. Emergence, I think, is one of the main ways I would characterize these type of platforms, or I guess at Stanford we've been calling them foundation models. I was immediately struck by GPT-3, by not the text generation, but the ability to do in-context learning. Right, this is something that wasn't programmed in and just seemed to have emerged. But if you look back at the kind of the history of how machine learning has developed, even back, we can go back to kind of early days of deep learning. The idea of learning features without hand coding them from scratch is a type of kind of early form of emergence, where you don't like edges or faces or cats or whatever kind of concepts just come out from just end-to-end training. And then with things like BERT, around 2019, we see that language models could learn certain types of syntax, again, in a very unsupervised way. But GPT-3 kind of tops it off with kind of in-context learning, which is, I would say, much more structural. It's kind of an abstract skill rather than some property of a particular modality. So I think scientifically, this is really, really fascinating. It does change the kind of the way we think about building AI systems in a way. Normally in engineering, you design a system to solve a particular problem, like translate sentences. But with foundation or platform models, you first train this huge model in a self-supervised way, and then it's like scientific discovery. You go in and you see what has it learned? What can it do? So this is really, as a scientist, I'm really excited, but it also means that these models are really poorly understood. And even when they seemed like if I can learn something like syntax or in context learning, what they're actually learning is really unclear because we know that they have lots of failure modes, as well. And also, I think we've only touched on perhaps the surface, what these are capable of. These are the things that we've discovered. It might be that there's other phenomena lurking even in existing models such as GPT-3 that we don't know about. And this is let alone the future models. So GPT-4 or any of the platform models developed today, they could harbor a lot of other things. I mean, also thinking about multimodality and things that just kind of opens up a whole dimension. So I think there are opportunities here. Well, there's a lot to be understood. I think, on the kind of the responsibility side, I think there's kind of reason to think a bit more carefully about we're building, as you say, our AI ecosystem around these models, and to have them built on the kind of things that just emerge is maybe potentially problematic. So I think we should really question what we're building AI systems on top of.
Yejin, what excites you most about the power you've seen in these models, and what kind of applications have you been developing? I always like to catch up with some of your late-breaking directions. What's happening on your team?
Yeah, sure. Actually, yeah, before going there, the power and also the limitations, which does motivate which applications. So I think a lot of us got very excited and surprised by how much of fluent language GPT-3 can generate. But at the same time, when we ask very simple questions, common sense questions, and depending on how we phrase it, it can perform quite badly. And when I think about it, I think it's the question of a pattern versus core concept, or surface patterns versus underlying core concept learning. And so it seems that we realize that the way that machines find a particular intelligent ability easy versus hard is very different from the way we understand what's easy versus hard for humans. So we would think that writing fluent blog post so that human readers come and engage should be much harder than answering a very short, trivial common sense questions about apples, birds, and how many eyes does a horse have, and that sort of questions. And I think this is an interesting new insight about what machines can struggle with, and especially the knowledge, core knowledge. And when I say knowledge, I'm not just talking about 2 + 2 is 4 kind of knowledge. It's also expanding to social norms and moral norms and ethical norms that humans rely on in order to live day-to-day lives safely and fairly with each other. So I'm beginning to realize that scale alone might not be able to bring all this underlying knowledge about the society and how the world works, the social and physical world works, and we might need to find a way to teach machines that knowledge. So at the same time, this pattern and core concept, these two things are not entirely separate. They are in the continuum, which means these large-scale models are learning a great deal of the core concept when they are close to the surface patterns and people spoke it out loud. So machines probably do know that the color of the sky is usually blue, just because people tend to report that in the language, whereas nobody talks about how many eyes a horse has. Therefore, machine may not know yet.
Let me ask you, and maybe open it up to anybody on the panel. What are the limits in the ability of these models to actually learn deep meaning versus shallow associational knowledge? Can deep, rich semantics emerge with these transformer models, with training based on just masking and prediction, the way we do self-supervised training? If not, what more, getting back to Yejin's comments and insights, what more might need to be done to provide these representations with deeper knowledge and deeper meaning? Anybody, feel free to jump in. Miles?
I can continue, or I could wait for...
Go ahead, Yejin.
Yeah, please. You're on a roll.
Yeah, so some recent research we did, which is not in the public space, but it soon will be, we investigate algorithms to better extract more correct knowledge, because off-the-shelf neural models might produce or generate sequence of a text that may or may not represent the correct knowledge. But we found that, well, algorithm always has been part of a computer science, and we can use algorithms in order to filter the knowledge down to something more consistent. And I think there's a lot of opportunity there. And in our recent work, we found that by doing so, we can build a machine-authored symbolic knowledge graph that's actually better than the best we humans have written for the purpose of causal common sense models. And so, and this is just one such approach, and I think there's a lot of opportunity, but it might just mean the importance of new types of algorithms to better extract that core concept.
And moving to another comment you made and also Percy made, beyond language, what's in store for large-scale platform models that might bring in other modalities like images, video, and combine that with language? Might we be able to maybe seek deeper embodiments that way, heading towards deeper common sense, wisdom, knowledge in these representations?
Yeah, maybe one thing I'll say is that often people conflate platform or foundation models with large language models. And this is just because of kind of historically how these models evolved from, with BERT and GPT-3 from the language domain. But I think obviously they are much more general, just the idea of, they are not at odds with grounding. So a lot of the complaints about how these models aren't grounded, I think, if you had much more grounded data, the idea of self-supervision would actually be very productive there. Just like how deep learning evolved from vision, but today we don't think of deep learning as specific to vision in particular. But I do think that there is a lot of opportunities. In particular, video I think is an extremely promising one. And I think vision, because of high dimensionality, the noise requires probably even more kind of scale and some level, and probably other ideas there to really harness the full potential. So I think in the next few years, even just kind of video alone will probably have a lot to say. And then there's the kind of interaction between language and video, which I think is super interesting. If you look at these even within language, these multilingual models, you could see that it's able to kind of take two languages and kind of embed them in a shared space, so that you're getting at something that's much more universal than the individual language. And hopefully by combining not just different languages but different modalities, we might be able to see even kind of more kind of learning of the underlying concepts.
So let me jump to Miles. Miles, what excites you about the possibilities forward for large-scale neural models? Where are things headed at the research frontiers of these models? And maybe at OpenAI, you can tell us what we can expect next.
Yeah, so I think, first of all, there's a lot of low-hanging fruit of just doing more of the same and, get even better results. So more compute, more data, more parameters. But I think what's more interesting than just scaling up is doing things differently. So using different objectives and different ways of combining human feedback to steer the system, so that they're not just, trying to predict what comes next in a string of text in the same way that it would, as if it had seen it on the internet. So trying to model the internet, that's, that does lead to interesting behaviors and does lead to an efficient way of soaking up knowledge. But at the end of the day, we don't want a simulation of the internet. We want a system that actually solves problems. So, for example, one thing that we've been working on at OpenAI is training systems to follow instructions. So it's not just you give it, 5 examples and then you expect that the sixth line of text will be similar to the first 5 lines. You say, instead of giving examples of poems, you just say, write a poem in the style of X. And it sort of learns through human feedback with human labelers and what we call reward modeling to actually perform the tasks in a way that is aligned with the human intention. And similarly, there are other sorts of ways of doing things differently. So breaking problems into smaller chunks. So just yesterday, OpenAI published a paper on recursive summarization of books, where instead of just trying to read an entire book and summarize it in one shot, which is a hard problem and goes beyond the length of text that GPT-3 can handle, you summarize small chunks and then summarize a few different chunks into a bigger chunk and so on up the chain. This is interesting both in that it can allow us to solve different kinds of problems, and it also allows us to oversee how GPT-3 is actually solving these problems and sort of check its work at each step of the way. And I think not just getting better performance, but better ways of overseeing these systems is something I'm really excited about.
Yeah, maybe I can add a little bit to that, just a kind of complementary perspective. I often think of these models as kind of unfinished, incomplete models. They're a platform or a foundation that you need to build on top of. So I think, in some ways, it's not that these models are directly should be deployed out. Like I don't think we should be deploying to a user like the raw output of GPT-3. And so I think it's interesting to think about what should we build? What should a kind of a platform foundation look like, so that the myriad set of people, application developers, can harness this technology in a kind of understandable way to build various applications that they would want. And what should that interface look like?
Of course, we have questions, Percy, about the nature of what the platform or foundation model should look like. We also have questions about what should the fine-tuning or the process by which we sort of generate application and user applications be like as well.
There's also a whole pipeline from the data collection.
Yes.
Where is the data coming from? How is it curated? What are the privacy? How do you think about privacy and data dignity and things like that?
Yeah, I find it great to be in a field where one panelist says, we're publishing something just yesterday or tomorrow, and another panelist says, I haven't published this yet, but you should hear about this. I'm so excited. So things are moving pretty quickly. It's interesting. Now, let me ask the group, let me start with Miles, about concerns about safety, responsibility, various ethical questions rising with the uses of these models, at least the current versions of them and the fine-tuning process that's currently in place. We can imagine this changing someday. We can even comment on how we might change things in the future to address some of those issues. But what are the current concerns about safety, responsibility, and more generally, some of the ethical questions that have come up with these models?
Yeah, so I think the way I'd put it is that because these systems are trained on such a generic objective of just sort of replicating text and trying to imitate the internet, essentially, that means that they can be used for a lot of good as well as bad and misguided purposes. So I would break the issue down into misuse, where that's just like simulating the text is just not something we want to do. So we don't want models where you give it a false headline and it generates a whole sort of New York Times style article about some fake thing that didn't actually happen, and then someone spews it all over the internet. So I would consider that a kind of misuse problem, where just the objective that these models are trained on is not something we want to support. And at OpenAI, we do things like having rate limits and quotas and sort of anomaly detection for patterns that might be correlated with those sorts of things. So that's sort of misuse. There's also unsafe use and just uses for which the model is too immature. It doesn't have enough world knowledge. It might it might be a domain where there's a higher risk of generating toxic outputs, or medically harmful outputs. For example, if you're using it for medical advice, there'd be cases where its biases could cause serious harm, such as asking it to make loan decisions, for example. So the way that we think about that is that we're still treating this as sort of a beta phase of deployment, and over time we're gradually scaling up the amount of people and the amount of use cases we can support. But for a lot of things that are high risk, we just won't be able to support them, and we're just not going to approve generating 1 billion tokens of text a day for some random purpose. That it has to be something that's consistent with our guidelines. And there's also the question of sort of what kinds of bells and whistles, like documentation and a human in the loop, are allowed to make a system that's not on our sort of red list, and not too high risk, but it's borderline and potentially a yellow light. And are there ways that you can make that better, such as by having an informed user and making sure that there's always a human in the loop? So I think there's a sort of a spectrum of things from very low risk to very high risk, and a lot in between.
Yeah, and Percy and Yejin, go ahead, please.
Yeah, I would be excited to build on what Miles just said. Two things in addition. So about the toxic language generation, for me, the reason why machines do that is really because that's what humans said in raw text out there. And so not only this presents an opportunity to reduce such harmful language from AI, I think we might also be able to better guide or inform people to avoid biased language, because oftentimes such a language is used by people who believe that they have zero bias. And another potentially interesting, but in my heart, a very important research direction to pursue is, in case these models become so powerful and become really even more deeply integrated with human lives, I think we need to really inject some sense of social norms and moral norms into these models better, so that it's not just about avoiding harmful things when generating text, but also understanding in general what are socially normative behavior. And so this is a little bit more forward-looking perhaps, but another coming up work that I think, Eric, you saw the preview of it recently, is common sense moral models that can do a lot of QA. And it's taught by basically human written textbook of moral norms and code that machines on its own cannot really decipher by reading a lot of raw text, which have questionable things, such as maybe writing a fake news is okay thing to do, which is not true. So it's almost similar to how, as humans, we have to teach our children what's right and what's wrong. And I don't think it's right for us to expect that machines can do that on their own, self-supervised discovery of moral norms. I don't believe that's possible. And we have to teach more explicitly through declarative knowledge.
Yeah, it's interesting, and another challenge that I've seen recently with playing with the output of in some of these tasks created with the platform models in language has been what I'm calling, instead of like analogous to the uncanny valley in user interface research in HCI, is I call the hidden valleys of looking at pieces of text that seem almost correct, but you have to sort of look at it very carefully to find the, wait a minute, that's not true. And so there's a concern that in daily uses, people might not put the effort in to see the kind of hidden valleys of erroneous information, even if shrouded by more correct sounding text or inferences. Percy, any comments on the your sense, perspective, your lens on safety, ethics, responsibility?
Yeah, lots of comments. I mean, I think this is a great topic, and we could have a whole panel on AI, responsibility, or a whole workshop.
Oh, I know. We've been through those panels, you and I.
Yeah, and I think it's especially important because I think there's a lot of work on kind of pushing the technology and business as usual, kind of scaling up. And it seems like they're very hard challenges, but there's kind of seems like a path. But I think AI responsibility is fundamentally much less developed. and partly because it kind of intrinsically involves not just a bunch of computer scientists or AI people, but we need to think about the social scientists and the people studying science and technology and society as well. I mean, I guess the way I think about it, there's a kind of a spectrum of subtle to catastrophic. There's like kind of subtle biases to kind of, let's say, misuse and kind of mistakes to kind of existential risk. And
I thought I heard the word catastrophic being formed on your lips just now.
Yeah, and I think all three are kind of different. Maybe I'm projecting onto a kind of single axis, but maybe different timelines / kind of different intensity levels. I want to pick up on the first though, these kind of biases. Because I think these are probably the hardest to spot and the ones where you kind of it's like the frog that kind of gets, boiled alive if you don't really pay attention to them.
A gently warming frying pan.
Yeah.
That's...
And I think it's, bias obviously, as we've talked about, is present in the data and it gets reflected. And, we talked a lot about kind of these generative applications, and it's sometimes easier to see where biases creep up. It's especially maybe easy to see when toxic content comes. But these biases, let's say you're doing recommendation systems or you're doing kind of, web page, ranking, which are, already kind of powered by these, platform or foundation models. These are kind of much more in the background, right? Like we talk about GPT-3 and we see what the model is doing, but I think most of the impact of these models is going to be completely invisible. Users will not see it, but it will subtly affect, what web pages rank and what people see. And if you're basing these on kind of much more personalized information, now we can have kind of more of an amplification of biases. And the problem with bias is that there's also a feedback loop where you deploy these models and behavior changes, and the data that you collect to retrain these models is going to kind of harden and entrench these biases even further. So I think this is a really important topic to kind of think about. And I know there's a lot of work kind of in the NLP community thinking about biases already. And one thing that would be great to do is kind of connect the intrinsic notions of evaluation of bias of the language models to their kind of end extrinsic harms that they do when they are adapted and deployed to real applications.
And of course, it's the case that we're already immersed in, all of us, and civilization these days in numerous recommender engines, search engines, other kinds of prioritization, from media to purchasing, to location, to services. And so it's not just large scale platform models that have these troubles, but it's already something we're grappling with as society. Let me pivot just a bit. I mean, not to give any short shrift to these very important topics that could take hours and weeks of discussion to even converge on definitions at times. Percy, and starting with Percy, is access and computing a growing challenge for university-based researchers? And I think the answer is going to be yes, of course. But what are some directions for democratizing the technology? How might academic research be better supported?
Yeah. That answer is the resounding yes. I think that one of the things that we don't maybe appreciate enough about the deep learning revolution is this incredible amount of democratization or openness and transparency, right? Where people share code and data sets, and you could just kind of get tutorials, and allowed a lot of researchers and AI startups and people to develop this. But these models are kind of reverting these, and sometimes the code and data sets and also the models aren't being released anymore. So it's kind of hard to have researchers kind of be part of this conversation. And I think that this is important because of such the wide range of social impact that this is going to have, that we just need not just academia, but just like as many kind of diverse voices as possible, kind of analyzing, critiquing, auditing, figuring out, and shaping the development rather than having it be concentrated in a few kind of the people who have this technology. And so I also point out that one could say, well, why do you need I should say that it's important to be able to train these models, right? So several models have been released. And a lot of research good work has been happening on understanding what the models are. But I think the thing is that the object of study shouldn't be the model, that it should be the process. Like machine learning is about how you take data and you turn it into a model that is useful for predictions, which means that you need to think about intervening on changing the architecture, changing the data, and seeing how these things manifest. And without the ability to do that, then you're just not able to even ask the right kind of research questions there. So what's the way forward? Well, I think that's a very good question. I think that so the other thing I'll mention is that it's some work can be done at smaller scales, but because of emergence, because in-context learning doesn't show up at 1.3 billion parameters, it shows up at at least maybe 10 billion, and you see it kind of in full swing at 175. You just miss certain things if you're only kind of working at scale. So that's another challenge. You need to train and you need to do it at scale. So what can we do about this? So this is where obviously industry and academia should kind of jointly figure out solution and figuring out a way to provide access to academia of not just kind of the models, but the ability to train and the ability to kind of be part of this conversation. And that's, I think, also we need to invest in kind of public infrastructure. So, Stanford was involved in initiating this kind of national research cloud, at least for a US. It's still kind of, very early days, but I think we also could benefit from having much more public infrastructure for sustaining kind of open academic research at a kind of a national level.
Any other comments on that, Miles or Yejin? Yeah, go ahead.
But Miles, if you wanted to.
Yeah. Well, I'll just say a brief thing, which is that I think, even I also agree it'd be good to have more public infrastructure on this. And I think, having sort of academic involvement in the training process would definitely be, having more of that would be valuable. I think it's also an interesting question of, what is the best way, what is the best set of norms for actors like OpenAI and Google and others to make the models that they do have, transparent in a way that checks off the various boxes of reproducibility and sort of supporting academic research and while still and as well as creativity and the arts and other sorts of uses which may not be sort of commercially viable, given that these are often expensive. Should these be sort of heavily subsidized? Should there be should it be free for academics? I think it's an interesting question of how you sort of best support that. And what should the norms be around? Should there sort of be a right to audit all of these systems that are being deployed? When sort of investigative journalists and other actors want to poke them for biases. At OpenAI, we've been trying to be pretty liberal in this and provide access to these models, but there's also some limits on. We do have some rate limits for security reasons and preventing misuse. And, what is the right balance between these things, between transparency and auditability on the one hand and misuse prevention, I think is an interesting question. And it would be great to see sort of, some convergence around norms for what to do with these existing models while we also think about better infrastructure.
And Yejin.
Yeah, so while I agree with everything that's said so far, I would like to add a different angle to this, which is that although it's important for academics also being able to study the internals of creating these models, I think academic people can also do complementary research that builds on these models from outside, and then be able to come up with really creative methods that could overcome any issues in the data. For example, if there were biased language or misinformation picked up by the model, is there an algorithmic way to suppress that or even disable it, because humans are able to learn to do that. Even if we were raised in a culture where maybe gender norms were very different, or there may have been more integrated sexism in the culture, one can still change as they age, and also they learn other cultures. They might change their mind, and we're perfectly capable of this continual learning. And I think we could do that with these larger scale models as well. And for that, I almost feel like this is an implicit collaboration between academics and companies like Microsoft and OpenAI. And, for my research, I feel like there's a definite, or many research, there's a, definite shift before GPT-3 and after GPT-3. A lot of new research can build on GPT-3's capability, and even the fact that we can probe what GPT does not know, or what sort of a toxic or biased language it might generate. It really gives a lot of insights to academic people about the importance of such research and how we might go about these limitations, really questioning the fundamental. And I don't think all of us should work on these quote-unquote foundation models. For that reason, we should also invest a lot on what to do on top.
Yeah. Thanks, Yejin. I should say that we're doing some exploration ourselves with the Turing academic program, with sharing out those models and working together to learn more from our university colleagues on how to work together and how to complement one another, as well as pushing on the core science. Let me ask everybody, might the border of what we call platform versus fine-tuning of these models shift or even melt in the future? For example, with the availability of more powerful computation or new methods with how the models are tuned or extended with massive data corpora? Or are we kind of seeing convergence and a fixation on the current kind of approach to handling, generating and using these large-scale platform models?
Yeah, I think already there's, the line is fairly blurry. I think in academic culture, it's easy to think about pre-training and then fine-tuning. But in practice, you have a pre-trained model, maybe on some text, and then you continue pre-training on some other text. So you can kind of think of a tree of possibilities, and they adapt it, and it kind of gets more adapted to the fine-grained task. That's one thing. And the other thing is that there's feedback, right? Now you deploy the system, maybe you get data. Now you have to go back and retrain your system. So kind of this model updating and retraining is something that's, I think, really important, because these are not models that you want to kind of train every day. But nonetheless, in real world deployments, the world changes and you need to update them. And then not to mention some of the things around kind of learning that Miles mentioned around learning from human feedback and getting additional pieces of information, which maybe depends on what the model is doing. So there's a lot of kind of cyclical stuff. So I think, you think about the pre-training and fine-tuning, that's kind of one coarse way of looking at one piece of the puzzle right now.
Any other comments on that?
I would just say that I continue to be surprised how far you can push foundation models, large language models, or platform models, whatever you want to call them. And in the case of GPT-3, for example, there's just so much you can do even without fine tuning, which I find really remarkable, and even entirely new kinds of things that weren't we didn't mention in the original paper, and people didn't really find good applications for several months. A year plus later, people are starting to think seriously about using these systems as data generators, and then sort of fine-tuning models based on the data that is generated and of a certain type. And then you have an even better model that's trained on that. And yes, Yejin is excited about that direction as well. So I think, even without fine-tuning, there's a lot, and I think we barely scratched the surface of what's possible with fine-tuning these models as well. So there's, it's really hard to say, how things will evolve.
Yeah, I was going to say that we're getting close to our time now, but I wanted to talk a little bit more broadly. Over the years in AI research, and I've been doing this research for long enough where I've seen specific waves of excitement rolling over the community, and they might be viewed, some of the previous ones, as akin to a monkey racing up to the top of a tree, exhilarated about being on the path to getting to the moon, but hitting a dead end. Are these platform models, foundation models, and this approach, are they on the critical path to more powerful, more general AI capabilities, or might we view the models as, and the whole paradigm as being a local maxima in some ways, exciting and interesting with learnings for all of us, but not necessarily on the path to achieving long-term dreams of AI, including, for example, it's not just an example, including the pursuit of the multiple, what I like to refer to as the standing mysteries of human intellect?
Yeah, I can begin. I would be very surprised if these go away in the foreseeable future. I mean, even if you look at historically, even machine learning, right? You developed, and you can wonder, whether machine learning is essential and part of the solution. Back in the 90s, I think this was maybe more of a debate. And it's not that machine learning has gone away. It's still very much with us. It's just that we think about kind of a different level. And then there's deep learning. You could ask, well, this deep learning is it the future? Well, again, debates. And it's not that deep learning has gone away and now we have platform models. Deep learning is the kind of the thing that powers platform or foundation models. And then the same with foundation models. I think it's a tool based on self-supervision that generates a certain set of capabilities. But I think over time, I think the framing and the way we view these technologies will definitely change. But I think these critical components will remain, and hopefully they'll get a lot better, more robust and reliable and more efficient. But I think that idea of generally building shareable infrastructure for a bunch of systems seems like a fairly some safe bet, right? Machine learning has traditionally suffered from this narrow idea. You train on the one data set and it doesn't even generalize to a different data set. And now we kind of have a much more general way of doing things. The other final thing I'll add is that part of these models deep down bothers me because they don't, having as someone who's worked on kind of more logical semantic parsing methods, they don't really, they don't understand in the same way that we would like to. But I think that's a bit maybe beside the point. I think of them as a very, very good system one. Like they're incredibly good guessers, soak in all the context. What's your gut reaction? What's the next word, or what's generate something? And I think we need still a system two, something that really kind of keeps our head on our shoulders in a way. That's something we haven't really kind of figured out. I guess there's things that in the past that maybe don't scale, and we need to kind of complete that picture of system one and system two to really have fulfill, as you put it, AI dreams in some sense.
Yejin, any comments on that?
Yeah, I think scale is necessary but not sufficient condition to making that leap to the moon. And so what's missing? I'm going to bet on knowledge, concept learning, proper concept learning. Even if we add logic on top, I don't think we are going to go very far without really teaching machines how to learn correct knowledge, correct concept learning. And the work that I think Miles mentioned in passing earlier about data generation offered from GPT-3, in my mind, it's also a form of symbolic knowledge distillation offered from GPT-3. And I think the true capability, right now GPT-3 is fascinating because of prompt engineering and because of long-form text generation, but I think we still haven't discovered what we are capable of offered from these extreme scale neural models. And in order to get to the moon, we really have to get out of the current learning paradigm and then look for new things that we can do that are different. And I want to emphasize the knowledge angle being a probably important missing piece going forward.
Okay. Miles?
Yeah, I mean, I would just add that I like a framing that that Rao Kampampati, former AAAI president and one of my professors of AI back in the day, he refers to these systems as having sort of wide but shallow knowledge, and compared to a lot of previous systems that were narrow and deep in their areas of expertise. And I think it's just a very different type of intelligence or understanding than we're used to. They're able to they're in some respects superhuman. Like no human can generate hybridize two types of poetry and generate 10 pages of that hybrid in in a few milliseconds. It's quite remarkable the things that you can do with these systems, but then they're just incredibly far short of human understanding in a lot of areas. So I think that's sort of my main update has been less about sort of the path to powerful AI and AGI looking differently, and more just like rethinking how we understand intelligence and what that path looks like, as opposed to how far we are away from it.
Well, thanks, Percy, Yejin, and Miles, for a fun and interesting discussion. We're out of time, unfortunately. We'll have to continue in other meetings. So research continues at a really fast pace, and it's clear we have a lot to learn about these foundation or platform neural models. I'm really excited to see how our understandings are going to grow and our methods are going to evolve over time. It's going to be interesting. Hey, can we... the four of us make a date now? I was thinking to meet up in 10 years, let's say in the fall of 2031, and we'll look back at how things went or where they went to discuss what came of the ideas that were shared today in our discussion. It will certainly be interesting to see how our current intuitions and reflections will be viewed from that future point in time. Thank you, Percy, Yejin, and Miles, for sharing your insights and perspectives with us today.
Thank you, Eric.
Thank you.
Yep, thank you.